warm good morning, my dear students. Welcome to this chemistry digital class. As yesterday in my live class and in that yesterday's video, we have discussed about the fundamental concept of organic reaction. Hope so you understood and you are now well aware about that how organic reactions are approaching. So in this particularly we are talking about mechanism, dear students. Mechanism is that how reaction occur. I'm talking about how. Okay, so in mechanism more focus is on how organic reactions are occurring. It is a sequential account of each step describing detail in electronic movement and energetic during bond cleavage and bond formation and the rate of transformation of reactant into product. That is called reaction mechanism, in which we studied yesterday that there will be one organic molecule which is called substrate. This substrate is a major reactant which is attacked by some other chemical species, and only by the attack of other chemical species this organic molecule is converting into product. Now I will talk about that attacking reagent. It is a reagent, so it means that it is playing like a agent only to provide those molecules which need to be substitute on hydrocarbon. So these are the species which attack the substrate in order to get major product. So these are two types, nucleophile and electrophile. And even we studied that the nucleophile are those reagent, those substance which attack direct on carbon nucleus of that organic molecule. Electrophile are those substances which attack on hydrogen, which is replacing hydrogen. It means that most of the electrophilic substitution reaction, electrophilic reactions are substituting reaction. Okay. Then if I'll talk about intermediate, there are two types of intermediate: the carbocation and carboanion intermediate, and carbocation and carboanion. Okay. If we will talk about cleavage, there are two types: heterolytic and homolytic. Heterolytic are those that cleavage which break down, which is not breaking into the same, which is not giving the same number of carbon. That is equal number of carbon will be the both side. The chain will be, the bond will will in the center. Okay, and carboanion are homolytic cleavage is those cleavage which is breaking. In heterolytic it is not breaking into same, and homolytic it giving us same type of chain. Okay, so in homolytic there are three free radical. Already we studied nucleophile, electrophile, whereas heterolytic carbocation and carboanion. This already we have studied in previous video also. Now related to same, today we will discuss why this cleavage occur, why bond start cleaving. Here we studied how chemical reaction is occurring. Now today's topic is why cleavage occur. Yeah, I can say how cleavage occur. Yeah, because of what cleavage occur. Okay, so let's stay tuned. So let us start today's topic. That today's topic is basic mechanism of organic reaction. Basic mechanism of organic reactions, or if I will say the basic principle of organic reactions, in which we studied yesterday that one of the hydrocarbon that will be treated with some attacking reagent and give intermediate. This we have studied intermediate. Then from intermediate it will get product. But my question is there now. Here this is playing very important role to form any kind of intermediate and product. Here you take any example of hydrocarbon. Take whether methane, ethane, propane, butane or benzene ring. The first step, first thing that will happen, then attacking reagent will approach toward hydrocarbon. That will be electron displacement. It means that electron will start displacing from carbon. Suppose if this is the basic hydrocarbon in which H, it is like this way. Now as I yesterday said, suppose chlorine is going to be attack on carbon or hydrogen, then this electron is going to be start displacement. This electron will going to start displace, where either it can displace this side or it can displace this side. Now if it will place this side, then on carbon there will be negative charge. then it will form carboanion. This we have studied yesterday. If this electron will displace toward attacking reagent, if that attacking reagent will attract this electron, then carbon is electron deficient. On carbon then will be positive charge. So because of that, carbon can have positive or carbon can have negative charge. Okay. So today I'm going to tell you the basic reason of electron displacement. So whereas there are two ways. Because of that, the electron will displace. So first is electron movement in organic reaction. Second is electron displacement effect in covalent bond. First, movement, how it can move, where it can move. So electron can move in organic reaction in two ways, as already we studied. One is homolytic way, second is heterolytic way. It is same the way yesterday we discussed that homolytic cleavage and heterolytic cleavage. Homolytic cleavage is what? Where cleavage of carbon is in same way. So see here the bond between C and H. If I will make this open structure of this compound, so the bond, this bond is going to break. You can see here this is break. This bond mean two electron. One bond can be made of by a pair of electron, in which one electron is of this carbon, one electron is of chlorine. Now suppose when it will start breaking, so carbon will take its own electron, chlorine will take its own electron. This type of cleavage is called homolytic because equal number of electron is taken by both the substances or component of the hydrocarbon. Whereas in heterolytic, what is happening? When suppose CH3Br, one hydroxide ion या nucleophilic ion या electron rich ion substance will attack on carbon, then what will happen? Obviously the bond will start breaking from here again. When bond will start breaking from here, both the electron will be taken by bromine. Why both the electron will be taken by bromine? Let me write the reaction which will be occur in between. 1 2 3 4 5 6 here negative charge. Now what will happen? HHH Br. Okay, now this bond will start breaking and both the electron which is there, that will taken by bromine. Why? Because carbon have other option, other negatively charged option, whereas in this case there is no option. So this positive charge will occur on carbon, then it is called carbocation. Cation का मतलब positive. So the name of this compound intermediate become carbocation. Now what will happen? This OH will approach toward carbon because carbon is positively charged, OH is negative charge. OH also want to give one electron and to become stable, and carbon also want to take any electron because to become stable, and bromine will leave. So this reaction will occur then. CH3 will now, in place of chloromethyl, bromomethyl, it become now methanol because alcohol will replace the bromine. Alcohol is more electron rich than bromine. Okay, so this is basic electron displacement. Now when the electron displacement is there in covalent bond, when electron displacement is there in covalent bond, it may occur either due to presence of some atom or group in the molecule or under the influence of some attacking reagent. या तो कोई ग्रुप एलिमेंट होगा जैसे OH होगा या COO होगा या CHO होगा या NC होगा, आपको पता है all the function group. Electron will start displacing from hydrocarbon either due to the presence of some atom or group of molecule or under the influence of attacking reagent. As a result, these electron displacement occur and centers of different electron densities are created. These centers are susceptible to attack by a reagent. It means that it creates some effect. Those effects we are discussing one by one. Mean electron will start displacing due to these effects, due to one of these reasons. The first is inductive effect. Inductive word come from induce. It come from induce. Induce होता है जबरदस्ती खींचना. So a covalent bond is formed on account of the equal contribution of electron by two atoms. In case two atoms are similar, the electron pair occupy a central position. and between the two nuclei the atom is such a bond is known as non-polar covalent bond. Okay, for example, if I will tell about the between H2 molecule, the chlorine molecule, carbon and carbon, these are non-polar covalent bond because there is no polarity, both the atom are same. But in covalent bond between two dissimilar atom, the where different electronegativities is there. Got my point? One is suppose chlorine, one is carbon. The bond between, I mean to say that inductive effect will raise in those hydrocarbon where two dissimilar atoms are there, where some one of the two, one is polar and one is sharing unequal electron pair. Then more electronegative atom will attract toward that X. With the result of that, X will acquire partial negative charge, carbon acquire partial positive charge. Okay, let's discuss. It is the process of electron displacement. इसमें वो process electron displacement की, in which electron along the chain of carbon atom, due to the presence of a polar covalent bond at one end of the chain. It is process of electron displacement of electron along the chain of carbon due to the presence of a polar covalent bond at one end of the chain. इसका मतलब है कोई भी कार्बन चेन हो, for example, if I will take example, any carbon chain, you take example of this carbon chain. Butane is there. Okay, here H, here H, 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 H. You know very well. This is simplest hydrocarbon. The name of hydrocarbon is pentane. If we will see between this carbon, which bond is there? Carbon, 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 carbon. Whatever bond is there between carbon, carbon, that is non-polar. Non-polar मतलब equal energy वाले. And between carbon, hydrogen, that is also equal. Now, if in place of this, one of the hydrogen will be replaced by chlorine, rest is hydrogen. So all these cases are non-polar except this bond. This bond is polar. Why? Because chlorine is more electronegative. Due to this more electronegative nature, chlorine will somewhere having more energy and it will attract the carbon electron toward its side. This side. In carbon will feel now partial positive. थोड़ा सा electron lose वाला, not pura lose. The complete lose of electron is not there, partial lose. You know very well when any atom, when it will lose electron, it will carry positive charge. Okay, that you know very well. So carbon is about to lose the electron, so that's why partial positive, whereas chlorine is about to gain electron, that's why partially negative charge. Now this, due to this partial positive and negative charge, the polarity which is produced, ये जो polarity that is produced in the molecule as a result of high electronegative atom compared to other is called inductive effect. This is called inductive effect. Now if I will tell example of same, this is having total negative charge, this carbon have, because this chlorine have total negative charge, this carbon have one positive because it will lose maximum toward this side. This have then 2 positive partial, this have then 3 positive, this have then 4 positive. So it means that as we will move, this electron of this carbon is gained by chlorine. Now small carbon is becoming loose, so this carbon will help this carbon to become stable. Now this carbon is becoming loose, so this carbon will become stable. Now this carbon is loose, so this carbon will become stable. Now it is more partial positive, so whatever hydrogen is there, it means that this hydrogen is now bonded very weakly. Okay, the positive charge of electron pair shared between C1 C2 toward itself, this will cause C2 to C3, so on. So it is a permanent effect in the molecule. It is a permanent effect on the molecule. This effect of electron displacement along the carbon chain due to presence of some electronegative atom is called inductive effect or transition effect. This is called transition effect also. Okay, so dear students, This is all about inductive effect. Now these are two type of effect, negative Y effect and positive Y effect. If I will explain a little bit what is negative Y, what is positive Y. Now first thing very that you need to keep, that is inductive. In inductive effect, whatever atom which is electronegative, it has electron attracting effect. It has strong electron effect, attracting effect. Okay, because it is electronegative. That atom which we have studied for this chlorine have electron attracting effect, not electron withdrawing effect. ऐसा एटम होना चाहिए जो इलेक्ट्रॉन खींचने की कैपेसिटी रखता हो कार्बन से, उस पर नेगेटिव उस पर आई इफेक्ट होगा, इंडक्टिव इफेक्ट होगा, अदरवाइज नहीं होगा. सो इन नेगेटिव आई इफेक्ट, इफ आई टेल नेगेटिव आई इफेक्ट, द एटम ऑफ ग्रुप, that electronegative atom of group has strong power of attraction. Okay, whereas in positive atom of group have less power of attracting. Okay, and it has electron releasing effect. If less power of electron, it has electron releasing effect. Okay, negative I effect and positive I effect. So important feature, it is permanent effect, and I will send you note. Second is electromagnetic effect. It involves basically the complete transfer of electron of multiple bond to one of the bonded atom in the presence of an attacking reagent. It is temporary effect. It is similar type, but it has complete transfer of electron in multiple bond. Whereas we studied in this, that was the effect due to electronegative. Here the transfer of electron of multiple bond from one to another. Okay, if I will tell in detail, a multiple bond consists of sigma bond and a pi bond. The electron of pi bond are loosely held, so that pi bond electron will start moving and it will become, suppose for example, if I take C double bond C, this double bond will start moving, and by reagent addition of reagent, the carbon positive carbon lone pair, it will become like this, because one side both the electron will go and it form like a sigma bond. The effect involving the complete transfer of shared pair of electron of one of atom joined by multiple bond, double or triple bond, at the requirement of attacking reagent. जब attacking reagent की जरूरत होगी तो ये double bond electron जो है वो shift होगा एक side को, and it will form electromagnetic effect. That's why it is called electromagnetic. इलेक्ट्रॉन को छोटा करना, मर में पार्ट करना, दो इलेक्ट्रॉन को सिंगल बना दिया, दैट इज कॉल्ड इलेक्ट्रोमैग्नेटिक इफेक्ट. इट इज आल्सो पॉजिटिव ई इफेक्ट एंड नेगेटिव ई इफेक्ट. पॉजिटिव ई इफेक्ट, when the transfer of electron takes toward the attacking reagent, when electron transfer toward attacking reagent की तरफ को मूव करेगा तो पॉजिटिव ई इफेक्ट. और इट इज इफ इट इज अवे फ्रॉम द attacking reagent, if away from attacking reagent दूसरी तरफ को जाएगा, then it is negative E effect. Okay, if it will go this side, then it is positive E effect. If it will go this side, then it is negative E effect. Okay, this is the main thing. Third is resonance effect, which is very important. If I will tell about resonance word is somewhere giving us idea about shifting of electron. Okay, an organic compound is generally represented by an electronic structure, and it is expected that the structure satisfactorily explain all the observed properties in which the electron are moving from carbon to carbon. It is also called mesomeric. Why it is called mesomeric? Because of intermediate. It is forming intermediate, and it is the effect, that is phenomenon in which two or more structure can be written for a compound, but none of them represent it accurately. Okay, mean we have same structure, same formula, same bond, but different position of bond. Okay, that is called resonance. The phenomenon in which two or more structure can written for a compound, as I told. Okay, for example, if I will take the structure of resonance of benzene, suppose this is a benzene and you know there are bond at number 1. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now if dear student, you will say carbon number 2, carbon number 4 and carbon number 6 had double bond. Yes, carbon number 2, carbon number 4, this is, and carbon number 6 had double bond. Now if we will see that its resonance will become like this. Now how many resonance will be? Now this bond of 2, it will come out. Okay, that's rest remains same. The number 2 bond will come number 3, 2 electron in the form of 2 electron. Okay, and this will become partial positive, this will become partial negative. Now this 3 will start moving here. That means that this bond will come out. Okay, because you know very well, one carbon cannot hold more than 4 bond. If you will see here, in this carbon there are 1, 2, 1 is H here, 3. In this carbon there is 1, 2, 3, 4. 4 bond is there. Then it will move here. So it will form double bond in this place, but that will give electron on this position. Okay, this means that electron will come out. Now this, after this, when this electron will move here, so it will come out. Then we will get next structure. Now in this next structure, this electron, these bond will be here and this bond will move here. So now if you will see, the bond will become like this. Now 1, 2, 3, 4, 5, 6. Now see, carbon number 1 have bond, carbon number 3 have bond, carbon number 5 have bond. If you will look, if you will see this structure carefully, so you will find that benzene ring is same. Only the carbon double bond position. Otherwise, earlier it was at number 2, at number 4, at number 6. Now it will be at number 1, at number 3, at number 4. This type of effect is called resonance effect, and it will create, this effect will create due to one more electronegative compound or one effect. Okay, structure contribution, if condition, I will say the structure contribution toward the hybrid must conform. The arrangement of atom must be identical. Resonance involves delocalization of pi electron and lone pair. All the conical form must have same number of unpaired electron. The energy content of all canonical form must be nearly the same, and all the resonance structure do not contribute equal to the hybrid. Okay, basically the structure should not disturb, only electron will displace. That is the resonance. Okay, and if we will tell resonance energy, the resonance hybrid structure is always more stable than any of the resonating structure. Mean these have more energy than any of the resonating structure. This first and last one is the first, 2, 3, 4, 5. So this is resonance structure of benzene. If question will come, draw the resonance structure of benzene, so you will draw these 5 structure, in which between 3 is intermediate and first and last is the complete structure. Okay, this is having 2 effect, plus R and negative R effect. It is also due to that plus R is when electron is removing, and negative I is when electron is gaining. Now last is hyperconjugation reaction. As the name is hyper, conjugated reaction, it means that somewhere no bond resonance it is. In this phenomenon, one hydrogen attached on sigma carbon atom with unsaturated carbon atom, mean double bond carbon atom. Okay, and it is a positively charged or odd electron, which are able to release electron by mechanism similar to the electromagnetic effect. Hyperconjugation is, dear student, it is the effect in which it is similar way like somewhere like resonance also, but no bond resonance. Suppose if I will take example of this, so you can see here in this carbon there is 3 hydrogen, 1, 2, 3. In this carbon there is 1, 2, 3, 1 hydrogen, whereas in this carbon there are 2 hydrogen. Now double bond is on this carbon. When double bond electron, which is most weakly, that will leave 1 electron, so this carbon is becoming positive, partially positive, and it will take electron from this carbon. Okay, and this carbon, this bond will become weak, so this hydrogen will remove. So in this way, we will get like this kind of structure, where now here it will be double bond, and in this way it will be one negatively charged. Okay, so now you can see here that bond which was there between carbon and hydrogen, that converted into double bond, and there is no bond between this carbon and hydrogen now, and this hydrogen become positive. And due to electrostatic force, this hydrogen will hold nearby this carbon. So this is called no bond resonance. Okay, no bond resonance. Now maybe this hydrogen will take this bond, and then we will get no bond between this and this carbon. Then this will take this, no bond between this and this carbon. So like this way, there is a one resonance, shifting of bond without removing the hydrogen. Okay, this is also called sigma pi conjugation, because this is the conjugation between sigma and pi. This is sigma and this is pi. Okay, so this is called hyperconjugation, and this type of delocalization is called hyperconjugation. So this is all about for today. Although if you are not if you are facing problem, if you face any of the effect problem, notes I am also sending, but please do study, and you can ask me anytime the question that you are not getting. So feel free to ask me any of the effect. So this is our today's video recapitulation. We have discussed today how organic reaction is going to be forward, approach by electron displacement. The first thing that is happening in organic reaction, that is electron displacement. Now why electron displacement occur? That is due to this effect. In every effect you have seen, I think the electron is somewhere displacing from one carbon to another carbon. I told you inductive effect, electromagnetic effect, resonance, mesomeric effect, and hyperconjugation effect. Okay, if still any problem is there, you can ask me. So thank you. Watch this video 2-3 times so for better understanding, and related to same videos, watch from YouTube channel. So thank you. Have a nice day.